Hi everyone. Last class uh, we started module 2, which consists of control flow and loops and functions. So we so control flow and functions. Control flow consists of basically conditional execution, such as the if condition and all, if match and all, and loops, which is sorry, con conditional execution, yeah, if and loops, which is basically while loops, for loops, and all. Uh, so today we'll be discussing about functions. So functions, as I had mentioned before, once or twice, I think, are blocks of code that only run when they are called. So they are like basic building blocks of code which we can use to construct like larger or bigger codes based upon it. So basically, a function is like a useful piece of code that groups together a set of statements or commands that can be run, that need to be run more than once, and maybe in different contexts. So these contexts can be captured by something called parameters, which we'll learn about in more detail. Uh, yeah. So basically, the user function is that you don't have to write the same piece of code again and again. And if there's one error in one piece of code somewhere, you don't have to change it in multiple places. So defining a function is basically very easy. So we just use the keyword def, we give a space, and then we write the name of the function here, which is say underscore hello. Then there's a bracket, and after that a colon, just like we had with if statements and loops and all. Then we just write what we want to do inside the function. So here we just want to print hello from Python. Note that when I run this code of block of code, there's no print here, even though we have a print statement, because we have just defined the function. In order to run the code inside a function, we need to call it with appropriate arguments provided. So here, since our function does not require any arguments, so any arguments that a function will need will be present inside this bracket. We'll see examples below. So now if I just write say hello and bracket, it should run the code inside the function. Uh, a function can be used to like return a value using the return statement. So for example, here on the code above, we did not really do anything. We just printed a statement. But what if we were supposed to do something inside a function and then return the value of a computation? So, for example, here is a function where we are trying to add two numbers. So define add two numbers, and inside the brackets, now we have what are called parameters. So number one, comma number two. Number one is our first parameter, number two is our second parameter. We just return number one plus number two. So basically, we are just adding the two numbers. Now to run this code, we'll need two numbers. So here, add two numbers, 3 comma 5, we should get 8. Yeah. And yeah, so since the function returns something, that's why this print thing comes out even without like we explicitly printing it out. Okay. So that value that the function returns can be stored in another variable. So for example, here we are like res equals add two numbers. So basically we are creating a variable res where we are storing the result of our computation, which is adding the numbers 3 and 5. Yeah. So now we can just print the value of res, which is 8. Uh, yeah. So hmm, we now we are just looking at simple examples of functions. Okay. So here is a function that to determine if a number that is given is prime or not. We're defining is prime, and the parameter that we want is number. Basically, we want to see whether this number is prime or not. Sorry. What we can do is we can just see if the number is divisible by any number from 2 to that number, like from 2 to that number minus 1, right? So if it has any factors other than 1 and itself, that's what we are checking for. So now we just print if that is the case, if like there is a factor like that, we print the number is not prime and we break. So for, here what we are doing for n in range 2 to number, we are just iterating over the range from 2, 3, 4, 5, 6 till number minus 1. If number percentage n is equal to 0. So basically if the remainder of dividing number by n is 0, print that number is not prime. Basically if this condition is satisfied, you basically there is a factor for the number, and that's why that number is not prime. So we just print number comma not is not prime, and then we break here, because once we find out one factor, we know that the number is not prime. We don't need to run the function for rest of the numbers after that. So that's why we are just breaking the for loop. Okay. Now, yeah, as I had mentioned earlier, you can use the else clause with a for statement also. So that's what we are doing here. Else, that is, if after checking through the whole range, if there is no such number, then uh, we know that the number is a prime. Therefore, we print that the number is prime. Now we test it out. 16 is not a prime, of course, and 17 is a prime. Yeah. Uh, as I mentioned before, here we are using the break statement to end the for loop as soon as we find one factor, because then we know the number is not prime. Okay. Uh, the other thing I wanted people to notice is that these this whole part of block inside the triple quotes is not run or printed or executed. It's just there. Basically, this if you enclose something in triple quotes, it's basically similar as writing a comment, but here you can like multiple lines of comment within those three uh, double quotes. And generally, when you define a function, uh, it's best practice to like make a triple quote here and write what the function is used for and what parameters it takes. It serves as documentation, and also if you come back to your code and look at the function, you know what it is for and what parameters and arguments you should give to it. Right. Hmm. So yeah, here is what will happen if we have the same thing, but we don't put the break. So if we are not breaking, we are not exiting the loop ever. So it checks from 2 to 15 what all factors the 16 have. So 2 is a factor. So it first prints 16 is not a prime. Then it sees that 4 is a factor. So 16 is not a prime. Then 8 is also a factor. So 16 is not a prime. And after the for loop, it goes on to print this. 16 is a prime. Because we never broke the for loop here. Right. If I just print the values of n, it should be equal to 2, 4, and 8. See? The other thing is, earlier we were stopping this thing using a break, but we can also use a return to just stop a function. So here instead of break, we just have return. Okay, and we just replace the statement with true and false. So basically, if you run this one now, it should not, it should run and should not print like this, because the return statement also serves as a break and it exits the function. Wherever if you write a return in a function, and that line of code is executed, the function is stopped. Sorry, and whatever value was there in the return statement is returned from the function. Huh. So many of the commands that we have been using before are like built-in functions in Python, such as len and range. Len helps us find the length, and range helps us make a range and all that. So now we'll talk about some functions that are particularly useful for data science, such as filter, map, and then use something called lambda expression to sorry magnify their power and carry out a lot of different stuff. Just a second. Sorry. Huh. So the map function basically allows you to map a function to an iterable object. Iterable object is basically something like a list or a tuple, something that you can use a for loop on to iterate over and get the items. Okay. So yeah, it allows you to basically run a function through a list easily. For example, here we have the function define square of number is number to the power 2. Okay, now we have a list called my nums, which has 1, 2, 3, 4, 5. Now, if we just map and we write the name of the function and the name of the list or the iterable, it will just map it and we have a map. Now, either we can iterate over the through the map or we can just call a list to get the result. So if we call a list, we get this. If we iterate over for item and map, print item. Sorry, item map square my nums. Yeah. So we'll just print the items one by one. Okay. Functions in map and all can be even more complex, such as this one. So basically what we have here is define splicer which takes a parameter which is a string. Okay. So if length of the string is divisible by 2, we return even. Otherwise, we return the first letter of the string. Okay, so my names is a list that we have, which contains lots of different names. Now, if we run a list through it, if we run map through it, so map splicer, comma my names, and we use a list to extract the results. We see that whenever there is an even number of letters in the word in the name, it prints out even, and whenever there's odd, it just prints out the first letter. Okay, was that clear? Okay, great. Uh, so next we have filter function. So the filter function basically returns an iterator uh, yielding items for which a given function is true. Okay, so basically you need to filter something by a function, and that filter thing will return a boolean. So like we earlier what we had in map is that we had a function and we had a list and we just wanted to run each item in the list through the function. So for example, I had 1, 2, 3, 4, 5, and I just wanted to square everything. But what if we just wanted to check something and not square or like modify the result? So now that can be done by using filter function, okay, which has a similar syntax to like the one we learned before, map function. So basically, what we want now is, let's say we have the same list 1, 2, 3, 4, 5, or some other list we have. We want to check if each of the numbers are even or not. So now we'll use a filter function. We'll write a function to check if something is even. Then we'll use the filter function to run that function through the iterable object, like we did before. So here we are defining a function to check if a number is even. If it's divisible by 2, then of course it's even. Now we have a list of numbers for which we want to check this. And then we have the filter object. So the filter object is also a filter object, like we had a map object. Here also you can use list or you can iterate over it to get the results. So now we'll just use list and we'll see basically whatever is even here will be captured. Whatever is odd will be left out because we are basically filtering by using this function. So whenever this function returns a true, that value will be kept. And whenever this function returns a false, that value will be removed from the list. Okay, yeah, lambda expressions. So these are like one of Python's most like useful tools. So like uh, of course we need functions to like reduce the amount of code we write and all that. But what if we just need a function to run once or twice in a very small context, such as let's say we had the function to just square something or the function to just add two numbers or something. But we don't want to like necessarily define a proper function and then use that function somewhere to like carry out the task because it's too much code. Okay. So Python, like to make things concise and to help you like make your code cleaner, I feel, has something called lambda expressions, which helps you basically create functions that don't have a name. Okay, so we can quickly make a lot of different functions without ever needing to properly define a function object. Then we can just use that function somewhere to carry out whatever you want to carry out through iterable or some other thing. So basically, when we want simple functions and we want it quick and like we don't want to change the function a lot or something, and so it's something that's very straightforward or basic, then we can use lambda functions to like reduce the amount of code that we have and like what make the whole code seem cleaner. But yeah, when we want something larger, when we want something bigger, we want something that's heavy and can do a lot of things, we generally define a proper function. So now we'll slowly change the function that we had earlier to a lambda expression. So here we have the function square, which basically squares a number. If we write square of 2, it should give us 4. Explained before how it works. Basically, the result is given as the number that was passed to the power 2. Okay. Now here we had a variable and then we were returning the variable. We can just remove the variable and just return the result of the computation like this. So we'll simplify it further. Sorry. We can also write the whole thing in one word. So once you have a colon after some function definition or some if condition or something, then you just add a space and then write if your function is just one line or very short, you can just write it here. And then you call square, basically works. Okay. A lambda expression is basically this thing slightly modified. Okay. So here I'm assigning the lambda expression to some variable, which we don't do generally. But yeah, we'll look at what happens later, like how we basically use lambda expressions. So here in this example, we are just writing the same function here using a lambda expression. Square is equal to lambda num colon num to the power 2. So basically, lambda is like the def keyword. It tells Python that we are writing a lambda expression. Num or whatever you write here before the colon, how many other variables and stuff, will be the parameters of the function, and this will be the return statement or the return value. So if we define this and run this, it should come to 4. Okay. So yeah, so here is an example of like uh, how to write a proper lambda function. So basically, along with map now, we are instead earlier what we did here, care of the numbers. So yeah. So in map, what we did, map this function to this iterable or list. So basically, we are doing the same thing, but instead of square here, we are just writing a lambda expression, and we are not giving it a name or defining a function properly anywhere before. So it all becomes just one line of code. So list we are doing just to get at the values. Map is what maps this lambda expression to the uh, list or iterable object. So again, we have lambda number colon number to the power 2. Basically, we had my nums as 1, 2, 3, 4, 5. So this is basically the square of that. And we are replacing the filter function, the function that we wrote to check if a number is even, again with a lambda function here, where we have filter, and here is the expression lambda n is the variable here, and n divided by 2 is like a remainder of n division by 2 is 0. If this is true, then keep it, otherwise don't keep it. And nums is the list that we had 0 to 10. Basically, we just have all the even numbers. Hmm. So here are some more examples of like lambda function. So you can use a lambda function to get at the first or any object of a string or a list or a iterable object. This is the lambda function defined. Here in this lambda function, what we are doing is we are just reversing a string. This reverse special thing we talked about in one of the classes, module 1. So basically, we are just reversing the string. We can also pass in multiple arguments. So we can use x comma y and write make Python return x plus y. Basically, we are just adding two numbers here. Sorry. Yeah. So mostly we'll be using these lambda expressions with libraries such as pandas, which we'll be learning about later, to basically extract things from data frames or like create data frames and update them and stuff like that. Analyze. So basically, here I'll explain the code later when we touch upon pandas, but I'll explain it briefly right now. So first, we are just importing the module pandas as PD, so we can use PD to call pandas, and we need to have installed the module before importing it here. Otherwise, it won't work. Okay. So now we have a data frame which says name and score. So name of people and score of people. And this is how it should look like. Basically, two columns, name and what score they got. So here, notice that all the names are in capital. So basically, what we want now is to create a column which has all the names in lower case. So basically, we are creating a column called lower name, where we are modifying the variable name, and we are applying a lambda function where we are just changing the value of the item in the column to the lowercase value. Okay, so that's all for functions. So basically, functions are like blocks of codes that you can uh, repeat and reuse. And you can use different parameters to call functions, and like so basically you don't have to write a lot of code again and again. You just need to write some code once and then repeatedly call that function to get different values. So here we can get 3 5, we can get 5 10, we can get any two values. We can just add them or like check if this prime or something, whatever we want to do. uh, yeah. Then we looked at the return statement inside functions and lambda expressions, map and filter. Another thing to notice is that uh, when we are creating a function and we have variables inside a function, the variables are generally only accessible inside the function. The variables are not accessible outside the function. Okay. So for example, if I were to modify this code as result is equal to number 1 plus number 2. And if I were to just return a result, this works properly. Okay, I get the answer 8 again. But what if I try to access the variable result? I'm able to do it here, because we had earlier created this value here. I just changed the name and then I tried to access result. It's not possible because this result variable is only defined inside the function and it cannot be accessed outside the function. However, if we are creating some variable outside a function, so for example, constant, let's say we have a constant called 4, and in the result, we always want to add a constant of 4. So now we modify the function so that we add number 1 plus number 2 plus the constant. But notice that into the function, we are just giving number 1 and number 2. We are not giving it the value of constant. The value of constant is defined outside the function. However, when we run this, we get the answer 12, which is correct, 3 plus 5 plus 4. Because the inside the function also, we can access variables from outside the function. Whatever is defined outside a function or outside a loop is basically in the main part of the file, the main intent of the file is basically a global variable which can be accessed inside loops or functions without ever referencing to it or passing parameters. The only thing you need to take care about is that these constants are defined before the function. Otherwise, it might throw an error where if you're just defining a function but we don't have the value of the constant defined. The other thing to remember is that whatever variables you create inside a function will remain inside the function. The same goes for loops also. So if you are creating something uh, like when we are using the for I in uh, something, we can use that I inside the loop, like whenever it's changing the variable number. If we access it outside after the loop, we'll just get the last number. We can't access it before. In function, we basically whatever we define inside a function can be accessed anywhere inside the function, but it cannot be accessed outside the function. So that was all that's there for module 2. So I have a set of exercises on functions which I'll be emailing you guys. Uh, Please do that and go through it. Next, we'll be moving on to module 3, which is basically Numpy. Okay. Yeah. So take a small 2-minute break. Yeah. So Numpy is basically an open source Python library that is used to work with arrays, numerical arrays. It contains arrays and matrices and other such data structures with efficient methods that can help us carry out multiple mathematical functions and matrix multiplication and stuff like that. So yeah, Numpy can be used to carry out a wide variety of mathematical operation on arrays, and it is the fundamental package that is used for scientific computing in Python. Most mm, most packages that uh, do computation or some sort of analysis or computation basically uh, depend on NumPy or build up on NumPy. So before that, basically a package is like a package or a module is basically a set of code that people have written and have published online for others to use. So mostly in packages, people define functions and other stuff like that, which other people can directly use in their code without having to bother to write all of them. So before we get started, you should install Numpy. You can do so by running pip install Numpy on your terminal. So basically, if you are in a Jupyter notebook, you would run exclamation mark pip install numpy That should be it. So since I've already installed Numpy, it says requirement already satisfied. But if you have not installed it and you want to install it without going to the terminal, you can do it here. Otherwise, in the terminal, you just have to write this thing without the exclamation mark. Pip install Numpy. Okay. Uh, yeah. So before, okay, we install Numpy. Yeah. For using Numpy, before we use Numpy, we need to first import it as a library. Ignore this piece of code. It's basically to uh, remove any warnings that might be there. So sometimes packages like Numpy, Pandas, and all that have a lot of different warnings, such as future warnings and all, which don't really bother us. But they're mostly about things that might change in the future or functions that might change in the future. So if you're using something like that, it gives you a warning. So we don't want stuff like that. That's why we are just using this package called warnings to remove these, filter out these warnings. Before we use NumPy, we just import it like we did for pandas in the last sorry, module. Uh, Import NumPy as NP. Uh, so typically NumPy is imported as NP and pandas. We've imported as PD because, of course, we are lazy people. We don't want to write a lot of characters. So yeah, we basically import NumPy. NumPy is too vast thing to cover. So we'll cover as much as we can, and mostly we'll focus on the most important aspects of NumPy, which are like vectors, arrays, matrices, and random number generation, which will be most useful for us in data science. In between, if we use any other things that we are not familiar with, I'll be updating you regarding the same in like future notebooks and all. But most of what we'll cover in the course and most of what will come in handy for your data science is covered in this. So NumPy arrays are like basically the main way we will use NumPy throughout the course. Uh, Arrays can be of two types, either vectors or matrices. Vectors are basically one-dimensional arrays. So like you can imagine it as a list of numbers with one dimension. Matrices are basically two-dimensional. They have two dimensions, uh, X and Y, or like rows and columns. Uh, Matrices can also be one-dimensional, such as a row matrix or a column matrix. But yeah, in general, whenever we create a matrix, it's mostly a 2D matrix. So we can create arrays directly by converting a list or a list of lists. So now we are defining a list, my list called 123. If we just call the function np.array, np here refers to numpy, the package that we imported just, np.array, and then we give it the keyword, give it the parameter, my list. It'll create an array using the list. So basically, this is the array 123. If we were to print the type of my list and print the type of np.array my list, it should be different. So the first one is a list, but the second one is a numpy n-dimensional array. So a general class of numpy arrays. So now next we have a matrix. So we have a two-dimensional matrix. So basically this whole thing in the first bracket, whatever is each element here in the first square bracket is a row. And in so each row is a list. And in each row we have items which are sorry, each of them is a row. And in each of the rows we have items which are column 1, column 2, column 3. So basically this is 1, 2, 3 will be the first row items. 4, 5, 6 will be the second row item. 7, 8, 9 will be the third row items. 1, 4, and 7 will be the first column things, and 3, 6, and 9 will be the last column items. So now if we print it out, for now it just looks like this. However, if we change it to a Numpy array, it looks much cleaner. We see a two-dimensional array. As I mentioned, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 4, 7, 3, 6, 9 on the columns. So there are a lot of built-in ways that we can use to generate arrays. One way was to use lists. Okay. We can also use the function np.arange, which behaves similar as range. Okay. So basically it creates evenly spaced values within a given interval. So if we just place 0 to 10, it basically start, stop, and step kind of. So here start is 0, stop is 10, so it goes from 0 to 9. Here start is 0, stop is 11, so it goes from 0 to 10, and step is 2. So it goes from 0 to 2 to 4 to 6 to 8 and 10. Okay. We can use the functions in Numpy called zeros and ones to create arrays that consist of only zeros or only ones. So, for example, this code here, np.zeros3, will create an array of just zeros, which has a length of 3, 0, 0, 0. If we want a matrix or a two-dimensional object, we can give two, what do you say, ranks or two, basically number of rows and number of columns. 5 here is the number of rows, 5 here is the number of columns. So we give that in a bracket inside the bracket. So now we have 5 rows and 5 columns. np.ones gives us a, a numpy array of the shape that we provide, but filled with only ones. Let's say we had to change this to 3, 4 to come as 3 rows and 4 columns. Right. There's another function that you might encounter in NumPy. So the thing here was the one we used before to create a range was arange. Sorry. The other function that NumPy has is called np.linspace. Okay, so basically there's like slight difference between linspace and arange. In arange, similar to the range function, we define the step of each increment. Okay, in in arange we define the step. In linspace we define the number of elements that we need. So for example, if I run 0 to 10 3 arange first, okay, we'll get 0 to 10 in steps of 3, 0, 3, 6, 9. However, if I run np.linspace 0, 10 3 start, stop, and number of elements, it'll give us just 3 elements, which are evenly spaced. So 0, 5, and 10. 0 to 5 is 5, and 10 to 5 is also 5, different. Okay. Now, if we use 0 to 10, 50, it should give us 50 numbers which are evenly spaced between 0 and 10. Basically, this is starts with 0, ends with 10. That's also something that you should notice. In linspace, whatever you give here, the stop value is also included in the list. However, in arange, the stop value is not included in the list. We have another function called numpy.i, EYE, which basically creates an identity matrix of the dimension that we want. So identity matrices are basically square matrices where only the diagonals are 1 and the rest is 0. It looks like this. So in the case of 4 cross 4 identity matrix, it is 1, 1, 1, 1 on the diagonals, and everywhere else it's 0. Okay. NumPy also has a lot of ways that we can use to create random arrays. So generating a random function or a random array and using that for your code is something that we'll often come upon in data science. So this is one of the more important functions that we use in NumPy. So basically, we have np.random.rand, which the rand here is a function The random here is another sub-module in the Numpy module. So np.random, and then basically here is a module inside Numpy called random, which is used to generate different kinds of random numbers. Then we have rand, which is a function. It takes in one variable. It takes in a variable to basically create a list of random samples drawn from a uniform distribution from 0 to 1, 1 not included. Basically, we want a random array of just two values, so that's what we get. If you want a random matrix of 5 plus 5, we can also get that. So that all the values range from 0 to 1, not including 1, and uh, yeah, all of the values are randomly drawn from a uniform distribution. Rand n is basically returns samples from a standard normal distribution, unlike rand, which returns just uniform distribution values. So here rand n can also have values which are less than 0 or greater than 0, because it's drawing from a standard normal distribution where the mean is 0 and the variance is 1. Yeah. So most of the numbers here should be close to 0, because it's drawn from a standard normal distribution which peaks at 0. If we want integers, random integers, we can use the function in the random module called randint. So the names are quite easy to remember. Rand is just from random uniform, rand n is random from normal, rand int is random integer, and stuff like that. It's quite user friendly also. So now we have a function randint, and we have a range from low to high. The high number here again is not included. The low number is included. So we get one random integer, 67. Now, if you want to generate more random integers, you first give a start, you give a stop, and then you give the number of values that you want. Now we'll get an array of 10 values randomly picked from 1 to 100. So there are certain methods that we will be time and again using on arrays that we should learn about. So first we'll define an array. Array is np.arange 25. So it's basically 0 to 24. And we have a random array, which is a random integer array from 0 to 49 and contains 10 numbers. Right. So basically, in the first case, we have 25 numbers. What if instead of just one dimensions of like this one row and 25 columns, we wanted 5 rows and 5 columns? But we accidentally did this, or this was the case value which was provided, but we needed a matrix of 5 plus 5. Sorry. So what we'll do here is we'll use the function called reshape. You type the name of the array, you put a dot, and then you type the method reshape. And inside the parameter, inside the brackets, you have parameters, which is like shape, number of rows, number of columns. And we get a beautiful matrix using the same data that is generated here. Note that the matrix is filled row, like uh, one row at a time, and the column values are filled. So it's 0, 1, 2, 3, 4, and the sequence is this, basically. Let's say we have a random array, which is this random R that we defined above. We want to find what is the maximum value in this random array. Let's say we are talking about features or something in data science. Let's say we are talking about some quantitative feature or something, and we want to find out what the range of the feature is, what is the maximum value that we are getting, what is the minimum value that we are getting. Now, since we have just a list of 10 values, we can easily just guess or just take a look at it and just uh, tell which value it is. However, if you want to do it for a very large data set, it's practically impossible to do it by I. So uh, NumPy has functions that can do that for us. So NumPy arrays, yeah. So now we have array dot max, which gives us the maximum value that is present in the array, which is 49. Basically, yeah, 49 is the maximum value. The minimum is 7. So then array dot min gives us the minimum value, which is 7. Okay. So let's imagine that we don't have this one-dimensional array. We have a large, like multi-dimensional thing where like there are different columns with like data frame sort of thing or Excel file or something where uh, different columns have different things. And there's one thing called a price. Let's say it's a house data set or something where like it's a house, what features it has, and the price of it. Then what we do, we want to find which house costs the most. What is the cost of the what's the maximum cost of a house in the data set? So we can just use the column of cost and we can print dot max using numpy if it's a numpy array. We can use that to get what is the maximum price of a house. We can use dot min to get the minimum price of a house. But what if we want to know which house is it which has the maximum value, or which house is it which has the minimum value? Then what we'll use is something called argmax and argmin. So array.argmax will give you the index where the array has the maximum value. So here the array has the maximum value in the first 0 index. So basically, if we run this, we should get a 0. Again, array.argmin will give you the minimum value that is present in the list, the index of the minimum value, which should be 1 here. Exactly. Okay. So methods are basically like mm, functions that are defined specifically for certain objects or like inside certain modules or something that we use. So basically something like this. If you have some array or some object dot some function, that's mostly called a method. Function is basically, let's say something that we have numpy dot arrange, which is more general. It belongs to the module, not to a specific array. Okay. Uh, then we have something called attributes. So attributes are basically like metadata. So let's say we have the array ARR that we defined earlier. We want to know what the shape of it is. Basically, we put array dot shape will give us the shape, which is 25 comma nothing. So it's basically a one row with 25 columns. Right. Let's say we reshape it to 1 comma 25. Now this is what it looks like. So note that the difference here is that it has one more bracket inside. Okay. So basically, yeah. Now we have flipped it over. It's like one row with one column with these many rows. Right. It's 1 comma 25, not 25 comma 1. Now let's say we reshape it to again 5 comma 5. Then we get the shape 5 comma 5. So this is when we need to train data or something and we don't know exactly what the shape of data is, or we want to reshape it or something, we can use reshape and shape attribute to get the shape. Hmm. Again, another attribute that people often use is the D type. So basically array.d type will give you what is the data type of the array. So in this case, since we are dealing with integers, it's int32. NumPy has slightly different data types than Python. Than Python is in like, yeah, slightly more elaborate data types. One second, I'll just share. We don't need to know a lot about all this, but like Just for context, I'm sharing. Yeah. So basically, bool is a boolean, which we already know. Byte is basically a byte character, a small, sorry, one character signed. Ubyte is unsigned character. Short is a small integer kind of. Integer is integer. Long is a long number. We have floats. We have singles, which are also float. Okay. Uh, yeah. We have a double, which is a double precision float. Okay, which is like which can, so these long double and all can store longer values of data or higher, not higher, basically like not higher amounts of data, higher values of data. So the range that they can support goes bigger because the memory they occupies and the memory they occupy is also more. So we use like long double or long int when we need to handle like very large values. Okay. So that might be the case sometimes in data science when you're using it, but most of the times you won't be needing it. Okay, so that's it for NumPy data types. Next, we'll continue. Yeah. Huh. Yeah. So next we have indexing and selection. So basically, like we indexed lists and all, we can also index arrays in NumPy. Okay. Yeah. So basically, let's say we have an array called np.arrange 0 to 11. We have the array which is just 0 to 10. Then we can just similar to list, we can use a bracket to index the array. The array bracket 8 will give us what is there at the index of 8, which is 8. Okay. Then we have array 1 to 5, which should give us values from 1 to 5. Okay. This is 0, 1, 2, 3, 4. The indexing is also 0, 1, 2, 3, 4. So it will be the same. Right. Let's say if we change this index from 2 to 11, now we have array 8, which will be 10, and this array will be 3, 4, 5, 6. Okay. NumPy arrays differ from normal Python lists. So these are the similarities which we earlier used with lists, and now we can use with arrays. But arrays we were using because of their other powerful features. So broadcast is one such thing. Okay. So basically, if we want to change the values, we can do it like this. Right. So basically, we have the same list to set 2 to 10, but the first five values, 0 to 5, we have replaced by 100. Basically, it's 100, then 7, 8, 9, 10. If you want to take a slice of an array, we do this. If you want to set the value of the array, value of a slice of array, we can set it like this. However, yeah, we're just modifying parts of it when we're right. So here what we did was we changed the first five values to 100. Then here we just took the first six values as the slice. Then here we changed the first six values to 99. So now we have 6, 99, then 8, 9, 10. Okay. So data is basically not copied. Okay. It's a view of the original array. So even when we are like assigning a new different array to be a sub array of this or something, and then we are doing some operations on that. It turns out that these operations are also carried out in the array. So it's basically not a copy. Right? Okay, we discussed about copy and all before. So this is also something you need to be careful about. So to get a copy, we need to explicitly copy it. Okay. The next thing that we learn about today is how do we index a two-dimensional array. Okay. So the general format to index a two-dimensional array is array, then one bracket row, the row number that we want, or the indices of the row number that we want, or the row numbers that we want, and the column, indices of the column number that we want, or the column numbers that we want. We can also, instead of writing two brackets, we can write both of it in one bracket and put a comma in between. Right. So now let's say we have a array, two-dimensional array, which is basically a 3x3 matrix here. Okay. Now we want to, if we index like this, just put one index. Yeah. We just put one index. We get the first row, 0, 1, 2. So that's the index, 0, 1, 2. We get the row number 1, which is 20, 25, and 30. Okay. Now, if we want the individual element from that row, we'll have to provide which column is it in. First row, sorry, second row, first column. So this is second row, first column is 20. So this value should be 20. Yeah, we can also slice a 2D array. Okay, so basically what I told you, here we have to provide the row and here we have to provide the column or list of columns. So basically row we are saying 0, 1, these two. 2 is not included. Here 1 and 2. So basically we are dropping out the 0th column and we are dropping out the second row. Right. We are dropping out the second row and the 0th column. So we are just getting these four values 10, 15, 25, 30. That's what we should be getting here. 10, 15, 25, 30. Okay. So while by using slicing, we can like generate small sections of the data frame of the matrix or index small sections of the matrix. Okay. Uh, yeah. So this is the bottom row. Basically shape. This is how we get the bottom row. So you basically write 2. You don't need to give a column. You can also do 2, comma, and colon. We don't write anything. So this just takes every value. However, if you don't write the colon, I think it will throw an error. It's not. Cool. So this is also, you can do this. You can just get the second column. So fancy indexing is basically something that allows you to select entire rows and columns of data that are like not in order, out of order. So basically, let's say we have a array of zeros, like matrix, 2D matrix of 10 cross 10. Then let's say, we have shape of the array. We are taking the second value from that, and that we are assigning as the length of the array. Basically 10. So remember, if I do array 2D dot shape, it should give me 10 cross 10. Because 10 is the number of rows and 10 is the number of columns. Here we are getting the number of columns because it's 0 index. So 0 is this, 1 is this. 1 is number of columns. We got the number of columns and stored it into a variable called array length. Then for I in array length, array I is equal to I. Okay. So basically here what we are doing is we are like using this array length that we have to iterate over the columns. number of columns and number of rows. Yeah. So iterate over them and to like change the value of each row. Basically, yeah, we are just changing the value of each row to be I. I is basically the range which is 0 to array length, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's better if I do it with different shapes. Cool. Basically, we have 5. What we are doing is we are iterating over the columns and we are changing the values. And the rest 4 are left out. Uh, so here there's a mistake. Here we need to take the row numbers, number of rows, not the number of columns we need. So after I do this, we get 10, then it should work. So basically we are iterating over the rows, not the columns, and setting the value of each row to 1. Right. Fancy indexing is also basically done by using 2 brackets instead of 1, and then you put the number of uh, rows or whatever you want. So basically, if we do this 2, 4, 6, 8, so the steps here before were the setup. Here is actually what we are doing. So basically, 2, 4, 6, 8 is basically the row number 2, 4, 6, and 8. Row index basically 2, 4, 6, and 8. And that's what we are getting. We can use any order if we are using fancy indexing to get a small subsection of an array. Basically, here we have 6, 4, 2, 7. So we'll get 6, 4, 2, 7 in that order. Okay, that's clear now. Yeah. We can also select some parts of an array using a comparison operator. So let's say we have an array from 1 to 10. Okay. We have a comparison thing, array greater than 4. So basically note that here we are comparing an array object to an integer. But we are not actually comparing an array object to an integer. We are basically comparing each value of the array to that integer. Is the value in the array greater than the integer? Basically, we get another array, which is like if this condition is true, it adds true. If this condition is false at the given index, it adds false. So basically, here it's less than 4, less than 4, less than 4, less than 4. So we have four false. After that, everything is greater than 4. So we have trues. So basically, we store this in a variable called bool array. Now, if we use this array and inside the square bracket we just pass this bool array. Okay, the result from the comparison thing, which is basically called a mask. Okay, so like basically booleans which have the shape of the data, sorry, the array are basically like you can use it as mask to like add or remove values that are like that you need. So basically, if I use this bool array over the array, it will basically drop out the values where the condition is false. It's basically like using a filter, and it will keep the values where the function is true or where the value is comparison is true. If I do this, I should just get numbers that are greater than 4. Okay. Now, if we do the same with uh, we can do the same in short. So basically, if we have some value x where we want to we want to just print out values in the array that are greater than x. So array, and in the square bracket, we write array greater than x. Basically, we just don't use a variable that like we used here. Then we'll just get 3, 4, and everything that's greater than 2. Okay. So that's it for today. Uh, I know it's a little more to cover Numpy, but I don't want to do that today because then like I'll have to give you 2 assignments for module 2 and module 3. Right. So it's better if I just stop here. Next class we'll continue from Numpy operations, and then I'll give you the assignment for the third module, and we'll move on to the fourth module, which is pandas, where we'll be handling data sheets and data frames and all. Okay. I'll meet you guys tomorrow at 6. Sure. Thanks and good night.